All right, guys, this is Coach Brian with the second page of your Unit 9 test review. So the second question asks, which of the following are equivalent to cosine x? There could be more than one right answer. So essentially what I'm trying to do is use my trig identities to see if I can transform these answer choices into cosine x. And if I can, they are one of the correct answers. So starting with A, I've got 1 over cosecant x. This looks like a reciprocal, and cosecant, using your hexagon, 1 over cosecant. 1 over cosecant, if that's the second divided by the third thing, like if you go up to your hexagon and you're like, oh, if 1 is the second thing and cosecant is the third thing, where did I start? I started over here at sine. So cosecant is actually the reciprocal of sine x, and since A is sine x, it is not our correct answer. B is cotangent x over sine. So what I want to do is I want to take cotangent and I want to rewrite it in terms of sine and cosine. And now I've got a fraction divided by technically a second fraction. So I want to keep, change, flip, which will give me cosine x over sine x. That's my keep. Change to multiplication, and then flip my second fraction. And so what I end up with is cosine x over sine squared x, which is not equal to cosine x. For 3, it's a very similar looking problem to B. I've got cotangent over secant. So I'm going to rewrite cotangent as cosine x over sine x. I'm going to rewrite secant as 1 over cosine x because that's its reciprocal. And then because I'm dividing a fraction, I'm going to keep, change, flip. Let me just erase this, or I'll make it smaller so I don't have to fully get rid of it. I'm going to shrink that a little bit from the one before. Okay, so I've got to keep the first cosine x over sine x, change to multiplication, and flip my second fraction. That gives me cosine squared x over sine x, which is not cosine x. Option D, I've got sine x times cosine x times cosecant. Well, sine and cosecant are reciprocals. And when you have the reciprocals of the same number, in this case, both of x, being multiplied by each other, they just equal 1. So 1 times cosine x equals cosine x. So D does equal cosine x. Option E is very similar. I've got sine x times cosine x times secant, and cosine and secant are reciprocals, and they're being multiplied by each other. So this one ends up equaling sine x times 1, which is just sine x, which is not cosine x. The next few here ask if this is true or false. So when it's true or false, pretty much you're going to try to take the more complicated side and see if you can make it equal the simpler side. So in this first one, I'm going to try to see if I can take sine x times tan x and make it equal cosine. So I'm going to start off by writing it in terms of sine and cosine. So tangent is sine divided by cosine. Sine divided by cosine. So if I multiply that out, I multiply across, I get sine squared x over cosine, and that does not equal cosine x. So I could try to keep going, but there's nothing that I can really do or rearrange that will eliminate all of this and make it cosine. So that one is false. Next, I'm going to take this left side, which is cosine squared x, and this denominator 1 minus cosine squared x can be rewritten as sine squared x. Well, cosine squared x over sine squared x equals cotangent squared x, which is not tan x, and so this one is also false, because these are not equal. Lastly, you got to know your reciprocals here for C. I've got sine x times cosine x times secant x times cosecant x times tangent times cotangent. So I've got all the pairs of reciprocals in here. Tangent and cotangent multiply to give me 1. Sine and cosecant multiply to give me 1. Cosine and secant multiply to give me 1. 1 times 1 times 1 equals 1. So the whole left side does equal 1. So this is true. Question 4 says use the cofunction properties to write an equivalent expression. So cofunction means I need to first find the cofunction, and then I need to find the complementary angle by subtracting what was given from 90. So in this case, sine and cosine are cofunctions. 21 and 69 are complementary. For the next one, the cofunction of cotangent is tangent, and 90 minus 58 is 32. Now, these can get a little confusing when they're in radians. So what you're going to do is you're going to get your cofunction. In this case, cosecant's cofunction is secant. Then you're going to take 90, which is pi over 2, and you're going to subtract the given angle. Now, if you notice, I left myself some room here, because to subtract fractions, I need to have a common denominator. And so to get 2 and 8 to be common, to be the same, I need to multiply this first fraction by 4 over 4. What that does for me, when I multiply across, is it gives me 4 pi over 8 minus 3 pi over 8. I have a common denominator now, so I can go ahead and subtract and get that the cofunction is the secant of pi over 8. So when you're multiplying fractions, you don't need a common denominator, but when you're adding and subtracting them, you do. Now the last one for this section says write an equivalent expression using a positive argument. And they go ahead and define that for us here, which is helpful. A positive argument. Argument is what's inside the parentheses. See how all of these are negative right now? I need to use my even and odd properties. So for the first one, I have secant. Secant is even. What that means is if I have the secant of a negative number, and let's say that equals, I don't know, y, then the secant of that same input but positive will also be y. So again, if you remember from 9.4, I have opposite inputs and matching outputs. That's the definition of an even function. However, cotangent is odd, which means if I have the cotangent of 50 and that equals y, the cotangent of negative 50 would be negative y. Odd functions have opposite inputs and opposite outputs. So odd, opposite, opposite. O, 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 O. Odd, opposite, opposite. So if that's true, then the cotangent of negative 50 would equal the negative cotangent of positive 50. So what I was able to do there is I was able to make my argument positive, but also keep the statement true. Sine is also an odd function, which means, simply put, if the negative is in here, I can move it out front and have a positive argument. And again, you can always test these in your calculator if you're unsure. If you type this into your calculator and this into your calculator, you should get the exact same value. All right, that's all for page 2. In part 3, we'll go over the final few questions.